Developer now for 7 years, 5 of which were in Poland. She currently works for the Craneware Group on a hybrid basis in Edinburgh. She's super interested in combining technology with her passions in psychology and dance as well to really help understand the inner self. So be careful what you say around her tonight because she might just get in your head. So without further ado, introducing our dancing psychology tech queen, Kristina Volk.
Okay, hello everyone. Yeah, I think it's been said enough about me. So I'm going to talk about this architectural methodology for front-end applications, but not only front-end, and we will talk about it later. We'll know about it later. Why not only? And yeah, so simply put, this is a bunch of compilation of conventions and rules, how to better structure your code base. And the main purpose is actually to maintain your code base in the face of ever-changing business requirements. And I'll start. Okay. Okay. So yeah, what we'll be talking about today, so it's actually about things that exist in our front-end world, then a little bit of history. We're not going to dive too deeply, just like a brief overview, and later we're going to find out like what we actually want from our architecture, and then I'll introduce the core concepts about feature-led design. And then I'll explain each layer and the responsibility of each layer. This is kind of like the base understanding of this architecture. Again, advantages and disadvantages and conclusions, and yeah, some like more stuff later. So yeah, it's been, as I said, it's been already said a lot about me. So yeah, just one thing that I'm kind of eager to talk about, like truth, what we all like have been experienced from time to time, and how we can actually address it in reality. So I'll start from my personal journey and from my personal story. When I was still a junior, and like, you know, lots of pet projects behind, no commercial experience at all, imposter syndrome, obviously, and finally I got my first job and met my first team lead, and he said, like, now you can forget everything that you've known before. And there were left with enormous, giant documentations about the project, and it took me like 1 week to comb through all of this, and then another week to find the initial place of the bug. And all my questions were like, why has it been written in such a way? And they all had the same answer. It has been always there, so don't touch it if it's still working. And then again, the technical debt was called actually, no, it had a deadline called after release, but obviously it never arrived. So then I moved to another company, and again, I met my new team lead, and he said, now you can forget everything that you've known before. And it's been my personal journey, but yeah, I think it's kind of got reflected something in you, in your own personal stories, and we are still like facing that problems, because actually moving from large companies, we have to learn like a new documentation of the project, like a new framework, and yeah. And it's really interesting that the front end has been existing like for about 30 years since JavaScript was evolved, but still, like, there are no clear guidelines and methodologies how to actually maintain the front-end applications. Well, they do exist, but they are very abstract and vague. So instead of that, we have like just a million articles about how to better structure your React, Angular, Svelte, and like any other framework projects. And we have, so one of the pain we have in our front-end world is actually we all have a really specific knowledge that relates only to one project. And moving from one to another, we cannot apply the previous knowledge from to like a new place where we are working, and it's kind of and it introduces like lots of project unique like snowflakes. Then if we dive into our code base, we can notice that our modules and components, they have connections, but they are so implicit, they're hidden. So every time when we refactor something, we never know that if we refactor that today, something will blow up tomorrow. And if we remove one feature, we are never sure about what unexpected bugs and side effects can bring us in future. So what happens in reality, we write code just like for the sake of working just fine, because there is never time in order to make it qualitative and qualitative enough for clean future reuse. And so the technical depth grows exponentially because, again, we don't have time. We borrow that time like from our business, but we never pay our debts. And it's very also difficult for new incomers to actually start bringing value, like business value, because we have to wait for them until they understand everything, until they realize all our unique architecture designs inside of our project. So we have to also wait for new joiners while they gonna go through all the stages of denial, and only then, with the help of all team members, they can start bringing value in our project. As a result of all of this, we get quite a typical picture on our front end. So, sincerely, we want to develop qualitative code from the beginning till the end. And we are really successful in the beginning because all the business requirements are clear, they're stable. And we are able to maintain this clarity of understanding about projects. But we know that business vision and requirements, they do change all the time. And it's very hard to maintain the same level of clarity and also to be sure that our code base is actually capable for new features to be developed. And and it's fairly sophisticated point and aspect because we simply cannot predict future, but we try our best. And so let's just try to recall the history, how the developers in the past were trying to fight with the same problems. And we can as well remind the phrase, I think it's from Buddhism, that the life is a constant battle, and front-end world is not an exception, because fairly we all have been fighting with the level of difficulty, or you can call it the level of entropy in our project. We cannot collapse the entropy like to the full extent. We are trying to react at the time when the pain arises. So, and we try to find the right tool in order to address that pain, because we understand if the project gets complicated, that it needs something else, maybe a new framework, maybe a new architecture, and so on. There was a word in the beginning, and the word was MVP, MVC, and so on. And they were working greatly. And we have been still referring to them. We have been still using them because this is our base fundamental knowledge. And when we didn't have specific requirements from business, it was fairly easy to maintain this structure when we open the project and we can see like modules, controllers, and views, and it was working pretty well. But since the front end has become so complicated, we just realized that this is just simply not enough. And then everybody is familiar with such concepts, with most of them. We all love them. We implement them, maybe not entirely and explicitly, but still we do that. But what's the problems here? What are the problems here? So the first one is the actual guideline in order how to apply them on the front end. All of them, they are too vague and abstract, and they do describe the ideal world. The second one is, but yeah, we know that each team has its own philosophy how to perceive the documentation about some kinds of technology, and because of that, they also interpret the best practices rules in their own way. And the second one is actually, if you try to follow them like strictly, you will find out that they kind of contradict each other. So let's take dry and grasp, which is not here, but yeah, let's take dry and grasp principles. And so first we try to develop our components to make them really reusable, abstract, so we put it like in a higher level of our layers, so other developers can, in a very easy way, use this module. And then we proceed the same work with another component, and then we kind of after some time realize that some modules that actually relate to one like subject domain, and they're supposed to be located like local first, but according to local first principle, they kind of spread over across the whole application. And in this point, we are very confused. So again, something lacking of clarity here. Then later, when we were moving, it was a very great example of how actually developers understood that we can compose our logic related to one domain, and we can keep it in a kind of module or component. Yes, so we did realize that actually we need to have components, but what about the connections between them? Because, you know, application is about interactions between the components. So that has been that was a big shout out to the subject domain. So it's like we have subject domain, and let's take that into consideration finally, because yes, technical development and technical realization is all great about the programming, but we are trying to execute the tasks of the business, and we have to comply with this. And we know that, again, it was applied in majority in backend, and it was a great example how we can actually take the subject domain from business and project that into our code base. So it wasn't hype. It was applied like greatly, and the it has touched front end as well. However, what's the drawback here? So the best practices were developed not in accordance to the UI needs, because UI is considered like an external dependency there. And but we understand that the business logic and components, they are so penetrated, like everything is penetrated with UI, so it simply cannot be just like outer dependency. Again, something not we wanted in the beginning. This is an example actually with the big shift on UI. So here the idea was really clear, and it was more about like to ease out the interactions between the designers and developers, because yeah, we have pages. Then pages, they are made up of templates, organisms, molecules, and atoms. So at least the components, they are enclosed in their own levels. However, in terms of like business, yeah, we know that we have lots of logic in connection of state management. So we have our selectors, reducers, actions, API calls, and we all have to store that somewhere. So again, that example seems to be another extreme from the DDD. That was kind of focused on the data logic. And so moving further, these ideas about how we actually can divide our components and apply this local first approach have been really promising. So, for example, if we have like user or a card, we can store all the processes related to this domain into one kind of place. And here, high cohesion, that we're going to talk about later, about this term. So high cohesion is actually high. I mean, one module is trying to execute its own task and does it and is doing it well. So everything that is actually changing very quickly, it's located close to each other, not like in the entire application. Yeah, so it was. What's the problem here with this approach? It was on hype and also like kind of popular, but there was a lack of documentation about how to migrate from one framework to another, and it was still like very confusing how to actually apply that into reality. And yeah, again, like the approach, let's create the folder features and yeah, happy days. So it just didn't really work. So later, first manifestations with the people who are from Belarus, Russia, Ukraine. So more people started actually manifesting about how to survive under the harsher realities in the front end. Started to be really popular, but you know, it hasn't ended all well. And just 4 years ago, some people, including Ilya Azin, they started reflecting about the architecture, what we actually want from it, and it was really like a big steps in order to find out what we can actually aggregate from all the best that that was already developed, and we can actually add some clarity of what to use and what not to use. And yeah, then we can actually come up with some kind of guideline for front-end applications. So let's talk actually about what is the ideal architecture then. And asking like developers, we all can come up with kind of the same answers. So we kind of all mind is connected. So we want to have like directional flow of data. It's really important because according to this, we can reflect the hierarchy of the whole project in our head, and it helps us with everything, like with our daily tasks, like fixing bugs, refactoring, so developing features, and so on. From the technical perspective of view, we want to have we want to have like explicit relations between our modules, so we can actually just take the module, use it, and we want to understand how to do it in a crystal clear way. Then we want to have control over our code base, so we can scale without like experiencing any pains, and we want to integrate new features without restructuring everything that we already got in our code base. Then, yeah, in terms of adaptability, so we want to have like between our modules, we want to have low coupling, so they don't have to hook up each other, and inside of the module we want to have like high cohesion, so all the inner parts of the module should be really connected because they are striving to execute one task or achieve one goal. And this is more or less clear, but what about how we can achieve it? So yeah, this is what I'm talking about. It's just like some kind of theory. Cohesion is here, coupling is there, and if we're gonna look at this corner, again, it's very popular actually in monolithic projects. And yes, like the modules, they do execute their task properly and do that really well. However, they all hook up each other. In terms of if we're gonna be really obsessed with our decomposition, then we can end up into this picture when it's like our modules, they are very abstract and they also like scattered across over applications. These the undesired option because again, the modules are very tangled. They're very connected, like in a very tangible way, and they are not executing their task well. And we are trying to achieve something which is here. So this is what I'm talking about, like low coupling and high cohesion. In terms of the practical way, how we can actually do that, so this is about public API. And we need to remember that we know when we develop a module, we develop this module not only for ourselves, but also like into the usage for our teammates. And we also know that we store a lot of stuff inside only one component. And think about it that way. So some stuff is not actually needed to be exposed to any other usage by other developers. It's not really nice that other developers can just take anything from your module. They can export actually anything. So let's call them module consumers. They want just like to take your module and use it. And this is the responsibility of the author of the module to think in advance and do like some forecast about potential scenarios of how this module can be used in other like scenarios, and then it can actually provide a layer where they can declare all the things that are necessary for usage of this module. So because if it's not happening, then both the author of the module and the module consumers, they do suffer because author cannot change anything inside of it. If they do that, then module consumers, they suffer because all the imports and exports, they're broken. This is more about that like anti-fragility of our module, because if anything is changed or modified in our module in terms of realization, then the usage of it should stay unbreakable. And how we actually integrate the module. So this is about shifting the complexity of thinking on anybody else or on later. What I mean here is that when an author of the module, they start thinking about the development and about the development, they should project all the possible scenarios. And because if it's not happening, then module of consumers, they have to think about it. And this problem is very connected with name collisions and also like export defaults. And the very popular approach is to provide aliases for that, but we understand that like if we see that like one developer provided like produced lots of aliases, it means only one thing, that they didn't think thoroughly in the way how this module can be integrated, it can be used. So this shift is happening here on module consumers, but do they want to think about it? Probably not, and they're not supposed to, because as I said, there are two levels of abstractions, like the module realization, and the other one is outer usage. So it's actually you can declare what things are necessary to for usage of this module. So yeah, still like we understand like what we want and how to achieve, but still like our application reminds us like a heap of dummies, and I think everybody is also like kind of familiar with this structure, especially in pet projects, but actually it's still not bad, because at least the components, the modules, they are enclosed in their levels by type. However, yeah, I want you to imagine that you are like on the top of the mountain, and you can actually see a lot. You and by the visual information, you've got scope of knowledge that you are responsible for, and as soon as you go down, you see less, and you're losing this sense of control. So the same is actually happening in the architecture feature slice design. So we've got our layers, and they are different from each other by the scope of responsibility. So something which is located on the highest level, they are very responsible because they know a lot. They know everything what is located on the lower layers. And for example, if we talk about shared, so this module is most stupid module, because it's actually blind, and it cannot use anything because it doesn't have any responsibility. So we learned that we have layer. It can be app, pages, features, shared, and some other. Then we also have a slice. This is if we try to slice our layer into pieces, and one piece is sliced. So this is actually our functional module, which also has its own scope of the responsibility, and this scope of responsibility is defined by the layer it is located in. And also we have segments. This is the stuff what slice is made up of, we can notice that actually we go from something very abstract, like shared, to the very specific business domains that actually hold a lot of knowledge about our application, because shared, it does know anything about our specific needs of the project. And yeah, let's talk a little bit more in detail about each of them. So shared, as I said, is the most blind layer. Why? Because it stores our, for example, UI kit. So very abstract, like buttons, drop-downs, models, anything like that. Also, it can contain some code that is useful for kind of configurations, but on a very abstract level. Yes, some lips. So usually in your applications, you put it in the folder common or utils, something like that. So it's actually applicable for the whole application and very abstract. And actually the layer shared can be shipped to one NPM package and can be shared between another backend services and yeah, among the whole team. So then entities, we go the layer up, one layer up, and this layer is about actually this is the first level that is telling us about something from our business. For example, if we have order, user, or card, we can actually define one layer which will be entities. So I put the example from my own GitHub. So for example, if we have a list of repositories, so one repo can be our entity. Moving up one layer more, so feature is actually our use case. If we recall a UML diagram, when we have for example, an actor and it can make some actions. So for example, login, search something, paint the wall. So this is our action, and we can define a use case for it. So this is again edit profile. It's our action. So we can also define it that way, and we can notice even now that edit profile is an action over profile, and profile can be an entity. So there are many there is many confusion about what can be related to the features or entities, but yeah, the main difference is that use case is an actual use case that brings some business value here. Then in terms of widgets, we go one layer up again, and so this is our compositional block that all the inner modules are related by some meaning. So it can be header, it can be navbar, sidebar, and for example, you have different pages. You can use widgets, but you can ship different stuff into it. But yeah, just by props or whatever, you can define it. Pages. Yeah, I think everybody understands. So one page stores the widget features or entities that are related only to one page, because one page does not need to know what's happening on the other. We are reducing the problem with cross imports here. And processes, there's an optional layer, but for example, if we think about some authenticating or ordering, so these kinds of processes, they touch different pages. So we have to bring it one layer up. And up, here we actually, this is one of the most important layer, because it stores the most useful and important stuff about all our application. Even like about some kind of infrastructure, how to set up our store, storybook, like testing environment, styles, and stuff, and so on. So let's just quickly have a look at the example with GitHub. So we have our shards, our UI kits. We can combine them into entities, then into features, widgets, pages, and like our app is ready. So there is a very important rule about all the layers. So it's strictly prohibited to use something from the same slide, from the same layer. So for example, shared, any modules from shared cannot use anything which is located above it. Entities, they can use only stuff from shared, but they cannot import nothing from the layers above. So yeah, this is more useful for understanding what I'm talking about. It helps us with that one-directional flow of data. We reduce coupling between our components. So yeah, one goal is actually achieved here, low coupling. And again, about directional flow of data, we can actually reflect our hierarchy in the head. We can classify each module on the layer. We can understand where to search it, how to modify it, and where to put a new developed feature or whatever. So we can actually also imagine that this is our cake, and we slice it with the knife of complexity or responsibility. And the second thing is, again, it is divided by level of danger of modification, because when I want to refactor something, I understand module and its location, so I can straight away see what are the modules will be affected. And I can actually feel it, how much stuff I will have to refactor, and that's like feeling of danger, of pain, it comes from down to top. So it helps with actual, like, yeah, it just helps with controlling the code base and maintaining it. Right, and yeah, so we actually got our application ready, and I could have actually stopped. I could have stopped here, and the developers of Atomic Design, they actually did it. But we understand that we also have got a lot of logic in terms of our state management, and we have to store that as well somewhere. And the developers of FSD, they came up with a unified, standardized approach how we can keep this logic that is going to help us with high cohesion of each module, and we can actually introduce the same structure to each module. So again, just a little summarizing. So we've got our layers, right? Yeah, they're actually located in not in the correct way, because they are located alphabetically, right? But you can actually do that with like with just adding one before the name of the layer, so it doesn't really affect in the understanding. Then we unfold our application. We can see that, so this is like the real example. This is my project of application with the FSD architecture. And that just gives you a feeling of what we can actually, how we can actually store this. So this is our slices, functional pieces, right? And they all have the same structure. This is our segments. And if we understand that, for example, each module, it has like some kind of view or representational parts, so we can store that in UI. And we can call it UI, and there can be like CSS, HTML. Then in terms of our logic, that what is happening on the page, we can store that in model. Inside of the model, we can put our selectors, actions, up equals, like services. Then lib is kind of just helpful code, again for executing task only of one slice, and some configuration file. We can also like store the feature flags. In terms of the public API, we can declare all the stuff that is exposable for others, disposable for others in index.js. No, I think it's not very new for us as well. So this is our segment. And yeah, this is one more example. So I'm keeping that a little bit different, because I just want to show that not all the parts, they're strictly obligated to implement, right? If you don't need something, if for example you don't need UI for some module, you can skip it, and that's fine. So yeah, this is again about yeah, we can also keep types in our module. And what we get actually as a benefit of this architecture, we can actually unfold our projects. And first, what we can see like business value from this. Our modules and components, they tell us a story. And also we can understand their interactions. Then it does help us to communicate well with our testers, designers, DevOps, project managers, and we can do that understanding like the same context, like in one language. Communication is very important in our work. Then we can, yes, now we can actually understand what the connections between the components and okay, yes. So yeah, it becomes just clear how to scale and manage our projects. And if we move, if we just take an example of kinds of legacy projects and try to find out, try to see how it can evolve, how we actually migrate from legacy projects to something more meaningful. So usually we can see this picture on the left, and we can notice that like our code is kind of scattered. So some parts that are actually supposed to be located together because they are about the same thing, they are spread over across the like some layers. And first what we can do, we can actually put take them out and put them into one entity zone and make it like unified and standardized. Here we continue fighting with the destructive desegmentation, and apply a local first approach. When we open our favorite folder components, we can see the following picture. When we can see different components, right? But if you zoom in, you can notice that header, for example, is very difficult. Is very different to something that is into add to cart. I mean, the level of complexity. There's just like header is very dumb component, but this is kind of complicated and it has lots of logic inside. So we can finally divide our components not only by their type, but also by their level of complexity. First of all, yes, we start from here. Usually, we have, so this architecture is called flat. There are different of them. We have also nested, fractal, but usually we start from this one. And yeah, this is our anarchy, like the mass chaos. Then we can define some pages and share it. So this is elementary level of how we can move to feature-slide design, because we understand what we can make very abstract in our application and what we can locate into the pages. Then when we understand that our pages they are too overloaded, we can define widgets inside of our pages, our compositional blocks that we can reuse again in some unified manner. And then when we develop a feature, I mean a feature from business, not feature from FSD, we understand like what widgets are bounded and what entities are inside. And here we try to predict like the other variations and options, how these actually how it will be used in future. And so this is again, we think now. We do not delay like any complexity in terms of thinking on later. We try to make an effort now, and this can be enough if your team does not suffer anymore, and it's actually helped a lot to your project according to the level of complexity of your project. It's okay to stop and not to divide further. Because some really large application, they can benefit from features. However, for like some really simple ones, that's just kind of landing pages. Obviously, this is overhead, this is over engineering. And it's very important to remember that the whole methodology, FSD, is not about how to adopt all these concepts incrementally, but it's more about how to naturally experience all the pains from their development and address them at their own time. And because this architecture gives us hints where the problems can be, for example, cross imports. So this is a sign that something is going not right. So maybe like it's time to change something. The architecture again like ships on us like different red flags that we can actually listen for it, stop, ignore it, and maybe like the approach of, oh, it has been always written like that, is not working anymore. It needs to be changed. Yeah, so no pressure, guys. You can choose whatever you want, what you need, obviously. For like kind of short distance projects, this approach from the left can be working well. But if we're talking about something which is like more a long term, probably this can be better option. And yeah, let's talk like just quickly about advantages. So we have if people, they know FSD, so we have, and you've got FSD in your application, we have like a less painless onboarding. It helps recruitment. The architecture is consumable straight away because it's made up of domain modules. So we can finally apply the knowledge from our previous project to a new place. In terms of business orientation, so it's very encouraged to use the business terminology in your project. Because it actually helps a lot. Just think about it, that you can work on some place in your application and without deeply understanding of other parts that are not related to this one. Our architecture our project obtains kind of predictive effect, like effect of prediction, because everything is put in a standardized approach, so we can intuitively predict things when we search for something. We try to fix the bug or refactor anything or develop a feature. So we can finally, we obtain this control over our code base. And in terms of adaptability, so we can remove our components with less danger. We can replace them. Again, we can even, like, some components can be written really bad. I mean, like, there still can be some spaghetti code or whatever, but at least we can actually use them in a safe way and refactor them later. So it's actually, again, it's applicable to projects of different sizes, but think first if you can benefit from it, like of what particular concept you can actually benefit from. We can finally do something about our technical depth. So, and like FSD, it also produces a nice way of thinking. You don't have to apply it to the, like, straight away, but still you can try to play around on, like, some small projects, because there are still some concepts that you can apply just without using the whole methodology. There are more practical guidelines because there is, like, a community, and even different versions they are developed. So now it's less actually difficult to start using this methodology, because it has been there, like, for 4 years, and many problems, they have already been solved. And even linters, they have also been developed for such needs. We all have standardization, like we have our project become more standardized. And obviously, talking about disadvantages, if you want to be hired, so you have to obviously be aware of such concepts. Then in terms of realization, so now if you take part into the development of something or of some projects, you cannot actually push your component blindly in the code base and just see what happens. You have to stop, take a pause, and make an effort in terms of thinking. So you cannot shift these like luxury of thinking about, like, some complex stuff on anybody else in the team, and at any other time in future. So and one main conclusion: it's not a magical pill, because simply it does not exist, and it's more connected with probably understanding your team culture as well, because, for example, yes, we do try to address like complex pains at the right time with a new tool. However, sometimes it can be a case that even your team might be not ready, might be not matured enough. And this is connected more with team processes rather than just like be excellent in technical knowledges. And sooner or later, we have to comply with this anyway. Yeah, think about if you need first day in your project, because if there is only one person working in the project, obviously they can maintain everything in their head. But if there are more people, maybe it's a good idea. Then the project is going to be scaled, and you can see that it's getting more complex because obviously, yeah, we have to come up with kind of some more complex architecture for more complex projects. UI oriented. Yes, we have. So this architecture has been developed according to UI needs and nuances. However, if you try to apply that to backend, you will find out very soon that it reminds clean architecture a lot. So some, for example, kind of popular application, which is chatbot, is written in FSD, and again, it's not really about frontend. If you don't really want to develop like a new bicycle or kind of invention, so yeah, you can take something that has already aggregated all the best, because yeah, let's be honest, like we do have great stuff, so why just not try to make an effort to try to use it all together. So yes, in terms of reality, like actually many companies, they do use it. They're more like from Eastern European world, so I just didn't want to put that on kinds of political reasons. Yeah, but they do have the community, and this is only proliferating. Guys, the developers of their architecture, they don't want to stay like kind of closed in their own context. So it's like great, like developers, they created like another front-end framework. Like, yeah, again, like what shall we do about it? And because they open into kind of collaboration and trying to adjust to the real needs from the teams. There is a community, there are some chats where you can discuss, you can find the solution to your problem first. And the second thing is actually you can chat about your problem if you face any. There are many examples of how you can actually start trying to implement that. Again, you can just try on your pet projects. There are articles about how to migrate, and yeah, this is so all the links, they will be after, but this is what I wanted to show. So there is lots of stuff has been already developed, especially with LinkedIn. Actually, I mentioned the problem with cross imports. And again, they've already developed like kind of a technology that allows you to use cross imports, but with a special like sign. So many problems, they have been addressed already. And yeah, so this is what I was talking about. Yes, guys, like do experiments, but remember that architecture is supposed and it should put on you some limitations on freedom of using the code or any programming language. However, it shall not leave like a destructive scars on your project and team as well. So yeah, this is so here I put the link to the main page where you can find everything. So yeah, thank you for attention.
seriously, well done. Like, that was awesome. A lot of people come up here and they can't like make eye contact with the audience. They're not as expressive as you were. You did a really good job there speaking, honestly. And the slides, like you had diagrams, like mountains, memes, videos. I mean, it's incredibly complex, and to describe something like that to an audience, like it needs to be visualized, and you did an incredible job of that.
Thank
so
you.
Seriously, well done.
Yeah, sorry guys, I want to ask you like if you have any questions. If not, then I've got a question to you. Like maybe you've already heard of it, or maybe you've tried to implement it. No, first time. Okay.
Does anyone after this talk think they might like to give it a try?
No pressure.
We got one hand in the back, so that's success in my opinion. So we don't have any questions in the room? Any comments?
So I guess like for this, in your experience, like I spend a lot of time like visiting new code bases, and sometimes you get the first slides that you show, which is just flat, and you're like, I don't know what anything is. Like there are just so many things here, and some of them are like literally React components that display a link, and some of them are full things. But then I think the opposite is sometimes a bit true, where you maybe go into something that's really quite explicit and you're like, okay, so the logic I'm looking for is in this file. Oh no, it's actually another file. Oh no, it's actually in another file. Do you find that there's a sort of tension there where actually the structure is too much, and you can't easily, you need to learn how to navigate the structure rather than kind of just knowing the application?
No, yeah, this is, I think this is a common problem when actually one component strikes into another and then another, and you forget the initial place, and you have to start again in order to find the same like kind of path. But if you have like something which is standardized, like in the segment that I presented, so then you obtain this intuitive effect. Like, oh, okay, so so I understand what I'm looking for example, like endpoint or like an action or reducer or whatever. So I can understand like where it's supposed to be located, and I can easily navigate to that place without remembering, because like these kinds of unified names, they are like my own lighthouses in the whole map of like of HIOS. So
Okay. Any other questions in the room? Can we get the mic down here? Sorry. Just get the microphone.
So if I'm understanding this right, the whole point of feature slides design is to systemize the design process and make it more readable in a way?
One of the benefits, yes. Like one of the purpose, yes. So we, like the developers of this architecture, they are striving to make the code base adaptive and scalable enough, because like the business requirements, they do change all the time. So, and we kind of want to reflect the same into our code base. So yeah, because obviously we cannot control everything. We can only like maintain this illusion of control. So, but yeah, with the concept of FSD, it becomes like more easy. It becomes easier. However, again, you know your project, your needs of your team probably, and based on that, you can take just some of the concepts of it and try to implement. And if it's like you feel that there is less pain, well, great. Like just like let's stay as it is, like in that place. If not, maybe try something else. So it's a trial error approach, and this is kind of promising because it's been aggregating, you know, the stuff that's like many developers invented.
Anyone else? Okay, well, I take that as a good sign, honestly. the sign of a good presentation is that you leave the audience without any questions at all.
No,
You've explained every single thing
it
about
means
feature
two
site
things,
design.
if like everything is clear or nothing is clear.
So let's give one big last round of applause for Kristina.
Thank you very much.
So just before we finish, just a little bit of housekeeping. So one thing that is super important that you do after this event is that you sign up for the Scottish Technology Club Bulletin. Jamie is going to be running, Jamie is going to be running a giveaway for CityJS next month. Next month, right?
So the conference is CityJS London. It's in April, but over the next month, I'll have a form open on the website where you can stick in your email address and you'll win a free ticket to CityJS. Ticket, but travel's not included.
There's always a catch. And then last thing from me, every time I host here, I always plug my own community. So I'm the founder of Scotland Remote Workers. We are a community which advocates for the remote curious here in Scotland. We have our third event coming up later this month, which is going to be with Petra Sundell of Upbeater. She's going to be talking about sales and marketing hacks in your freelance careers. During this event, we're going to have a giveaway from Social Hub, as well as an exclusive offer on a really cool AI tool. So please join us. There'll be more information on that on LinkedIn very, very soon. So that's it from me. Kristina?
Thank you very much.
Awesome. Well, thank you very much, and thank you to Eagle Labs.
In the last year, Scottish Technology Club has run over 20 events and we are now over 3,000 members strong. But we need your help. We've set up a Patreon page, so if you're able to support us from as little as £1 a month, then you'll be helping us grow our meetup groups, run more events and bring in higher profile speakers. So please do check out our webpage, click the link and see how you can support us today.